By the end of this unit, you should be able to explain the fundamental aspects of the data ingestion process, explain the pros and cons of data warehousing and similar technologies, and employ sparse matrices from SciPy as a scalable target destination. ETL is still used today for simple use cases, usually as part of a larger process. However, the complexity of today's data-intensive use cases precludes the use of ETL in most large enterprises. For these reasons, we refer collectively to the content of this part of the AI enterprise workflow as data ingestion rather than ETL. The archaic process of ETL has given way to data ingestion approaches that emphasize the use of massive amounts of data in place, where analysis tools are used against data sources that have not been moved or transformed. This approach allows for much more flexibility since the transformation of data is isolated to each individual pipeline that is accessing a large data source. Different pipelines can be used to flexibly transform data from a large data store. Large data stores are the norm in large enterprises. The concept of a data lake reflects this reality. Data lakes are very large collections of data stored in their natural formats, usually as object blobs or files. Today's data scientist must be proficient in building data pipelines that tap directly into such large collections of raw data, then process the data to gain insights. Along with data lakes, technologies such as Apache Hadoop enable large enterprises to store very large amounts of data and to access the data quickly for analysis. Hadoop has two advantages that make it useful in large enterprises. First, it's designed from the ground up to be fault tolerant. A Hadoop cluster runs on an array of individual commodity servers designed to cleanly fail over without loss of data or processing power. Second, Hadoop clusters allow for parallel execution of data analysis code against the blocks of data stored in the cluster. This enables the rapid execution of complex analyses against huge amounts of data. While many data ingestion pipelines draw data directly from sources such as data lakes and Hadoop clusters, data scientists in large enterprises will sometimes work with data engineers to build a data warehouse. A data warehouse keeps data gathered and integrated from different sources, such as a data lake, and stores the large number of records needed for long-term usage by machine learning systems. A data warehouse is typically built using data extractions, data transformations, and data loads. After selecting data from the sources of origin, data ingestion procedures resolve problems in the data and ready it for research and modeling. Modern large enterprises have adopted sophisticated data management processes and systems to handle very large amounts of data. With large data sets and complex use cases, data ingestion involves the ability to use data from a wide variety of sources, mixing and matching those sources to create data pipelines that feed machine learning models. Cleaning, parsing, assembling, and gut-checking data is among the most time-consuming tasks that a data scientist has to perform. In fact, the problem is not new, as statisticians have been dealing with the same dilemma for many decades. The time spent on data cleaning can start at 60% and increase depending on data quality and the project requirements. One could debate the proportion, and surely it depends on the team, the data, and a number of other factors. But one statement that is difficult to argue against is this: very significant portions of time are often devoted to data ingestion pipeline. Data engineers exist in many organizations to ease the burden of the data ingestion process. If the target data source is a database, then there are some useful tools and procedures under the umbrella term of database testing. Data warehouse automation is the general term used to improve the overall process of data ingestion. Testing is an essential piece of data warehouse automation because the quality of downstream models are tied directly to the quality of the available data. Testing can involve comparing large volumes of data, which may contain millions of records. The size of the data can pose challenges, but in some cases, a more significant challenge can be heterogeneous nature of data. You may find that you are using data of various types and sources, such as flat files, relational databases, open API feeds like Twitter to XML web services, and many others. Connecting all these heterogeneous sources in a standardized way can be a non-trivial task. With more sources of data comes an increased need for testing.